is balanced against the temperature sensed by the cabin air sensor and the position of the automatic temperature control knob. The control box will adjust the hot air mixing valves until a balance is reached between the three sources of information. Thus, if the temperature in the duct changes for any reason, the temperature control box will adjust the position of the mixing valve as needed to ensure the cabin temperature remains constant. If the cabin temperature changes, say due to different ambient air temperatures in flight, the control box will adjust the position of the mixing valves to compensate. The fresh air system consists of a fan installed on the left-hand side of the nose baggage compartment and the associated ducting and controls. The blower is located below the left-hand aft baggage compartment floorboard. Outside air is drawn into the compartment through scoops located on the side of the fuselage. The blower outlet duct contains a flapper-type check valve to prevent reverse airflow out of the cabin during pressurized operations. Independent ducts route the fresh air to outlets located at the intersection of each pilot switch panel and the side console. The electrical circuit that controls the fan includes the use of the nose gear up limit switch to turn the fan off in flight, even if the switch is left in the normal position. The type of fan used in the system limits its speed by working against a load. If it is unloaded, it will overspeed and damage itself. When the aircraft is pressurized, the check valve will close, which will cause the fan to be deadheaded. This will unload the fan and can lead to an overspeed. This often leads to damage to the fan. When the nose gear is retracted with the fan switch left in the normal position, the circuit to the fan will be broken by the gear uplock switches, even if the cockpit switch is in the norm position. An override position is also provided, so that during periods of unpressurized flight, the fan may still be operated. When the fan switch is in the override position, this circuit bypasses the gear uplock switch and turns the fan on regardless of gear position. While most of our discussion up to this point has concerned heating and cooling of the passenger compartment, several means of distribution are used in the cockpit as well. Heating air is distributed primarily through large floor-level ducts located forward of the pilot's and co-pilot's feet. The output of these ducts is controlled through a conditioned air knob located on each pilot's side console. Window defogging is accomplished through distribution tubes located along the side and center windshield that blow conditioned air across the window. There are no controls for the system. Since both the left and right conditioned air and cold air systems are interconnected through crossover ducts, air will be furnished to the window defog system anytime one bleed air system is operating. Also located in the cockpit, just aft of the co-pilot's chair, are the controls for the cold air dump valves. During winter operations, all cold air eyeballs are normally closed off. This could allow excess pressure to build up in the cold air duct system, and leaks in the system would just make heating the cabin more difficult. The cold air dump valves allow this cold air to be dumped into the fuselage aft of the cargo compartment.
The heating and cooling system is usually very reliable. When problems do arise, they are usually because of either a component failure or a problem with the plumbing that distributes the air to the cabin and cockpit. Until our next program, good flying and good maintenance.